Hello, Year 8. So now we're going to be looking at some specific types of quadrilateral. We're going to start with a parallelogram. Parallelogram is a quadrilateral with opposite sides that are parallel. Please can you pause the video and copy the blue box and the diagram. Now there's some properties that you need to know about a parallelogram, apart from its opposite parallel sides. I just thought I would introduce you to this notation. So hopefully you've seen it before. We can say that AB is parallel to DC. So instead of writing the words is parallel to, we can write these two lines here. And AD is parallel to BC. Now you'll see that I've got one arrow on these two sides and two arrows on these sides. The reason for that is that if I just had one arrow on BC and AD, then that would be saying that these sides are parallel to these sides, which doesn't make any sense. So we put two arrows so we can show which one is parallel to which. So opposite angles of a parallelogram are equal. Now we can prove these things, but we're not going to worry about that now. So on your diagram, can you put a single line to show that the angle at A is equal to the angle at C, and a double line for the same reason as the double arrows on the angle at D and the angle at B. So these opposite angles are equal. Opposite sides of a parallelogram are equal. They're the same length. So hopefully you know that a line means two things are the same length. And I'm going to put two lines here. All of these things I am adding to this diagram, can you add to your diagram too? The reason we're doing this is so you don't have to write out all of these sentences. The diagonals of a parallelogram bisect each other. What that means, and I'll change my colour here, diagonals, remember, join up opposite vertices. So I have this diagonal and I have this diagonal. And what I can say is that this length, I need to give it 3 lines, is equal to this length. And this one, which I need to give 4 lines, is equal to this one. So there's lots of stuff going on there, but we can just separate each thing out. Okay, so now we're going to use these properties to solve problems. While we're solving these problems, we need to make sure we're giving reasons for each step. So I need to find the values of all of the different pronumerals in this diagram. I'm going to start with the angles. So this angle here, alpha, is vertically opposite this angle here. This angle here is opposite in the parallelogram 108. So I can say that angle JKL equals 108 degrees. My reason, which I write in brackets, we write the whole thing out, and then because I know that this is 108 and they're vertically opposite, I know that alpha equals 108 degrees. Now, let's have a look at beta. These lines here are parallel because they're sides of a parallelogram, and this is like an intersecting traversal, if you remember your angles and parallel lines work. We know that this C shape, they're co-interior angles, and they are supplementary. They add up to 180 degrees. So I can say that beta equals 180 minus 108, which is 72 degrees. Because co-interior angles are supplementary. Now let's have a look at my x and y. They're on the diagonals here. So I can see that x must be equal to 4 because now the other diagonal, I've got 6 minus y and y. I know that they're equal, so 6 minus y equals y. This is the same reason as I've written above, so I can just write that there. Now I need to solve this equation, so I need to add y to both sides and then divide by 2. So for each question, you need to write your working or anything that is equal, and then write a reason out in full. This is all you need to do. Question 5 from exercise 13A. Writing reasons for every single one. Thank you.